All right, here we go again for another really quick tutorial to help a friend out in one of the CNC Facebook groups. So here's his model. This is just a screenshot. And the problem he's having, and here's his toolpath real quick. We can see he's using a 1-inch diameter ball nose. I don't know the dimensions on this, but knowing that's what he's using to cut with, I just kind of BS'd my way through it to get the same similar shape. But the problem he is having is this chip out right here. So I'm gonna attack this little project in a way that's probably not really conventional. I'm going to attack it to where I do these shapes first, even without modeling anything else. But anyway, enough rambling. We're going to do this. He's working in Carvico, it looks like, so I'm going to be doing this in ArtCam, so it's really close to the same thing. So if we look here, we can see here's what my model looks like. You see there's no center hole, and I've got my outlines here, and you can see that I've made a piece of material. This would be his actual piece of material here, but I made this larger. So when I create these tool paths, and the way that I'm doing this, that I had to group these together and these together because I'm rastering with the grain in this direction, and I only have a finish, but you would want to do a roughing toolpath and leave a little skin there so you can do a really tight, nice finish pass. I'm not going to model that. I'm just going to show how I got these to go one direction, and then if we look up here, I've got these to go another direction. And then another thing that you'll notice is this is the circle. I have this toolpath extending into that circle, but it's not bored out yet. And I have it going past the actual material. And the reason for that is anytime you create a toolpath with a ball nose, and let me just simulate this really quick. Okay, we'll just do a fast one. So anytime you do something with a ball nose, you always have the radius of the end of the tool to contend with. So if it was to have stopped right here on this, that radius would be inside this pocket. But by having it come out further, we can get it to where all of this shading here, which would be all of this, is outside of our part. So we don't have to go in and do anything special with that. And with these four, I call them divots, being shallower than this pocket, then the next thing we would do is come in here, extrude that down, and then just create a tool path working from the center outward, and it will actually remove all of this part. And this will just be cut in air because our material is not this wide, it's this wide. But here, let's show the reason why I did that. So let's get rid of our simulation really quick. If I sound winded, I'm sorry. But here, we can just do this. Go here and here, and we will just zero that out. Which one is it? Is it this one? I can't remember. It's thinking about doing something. Did I just lock up my computer? Okay, so here we have it. So now I'm just going to come over here and just double click this toolpath, which is just doing these. And the way I got my raster to work is here we can see I've got this going 90 degrees. If this angle here was set at 0, it would have rastered left to right. Do it at 90 and it rasters up and down. So these two would actually be at a raster angle of 0. But here, let's just recreate these real quick. All right, so let's look at this. So here we can see that by having the material the size of, or having this model the size of the material, you can see it will come down here because we still need it to come out so we don't have that the dish or the radius at the end of this pocket, it would then try and go down to the side and then go on the bottom or your Z, your bed, I guess would be depending on where your 0 point is, but it would try and go to your bed. So by lying to it and telling it that we actually have this extra material here, it'll just go straight out. It'll never go down, damage, or touch the side of the actual material that you're cutting. So that's why I did it this way. And who knows? I don't know that material. I don't know what type of wood it is, but you may find out that you would want these to set it at the different angle and these at 90 just to go either with the grain or against the grain. And then this would be nothing more than doing an F12. And let's just drop this down. So if we do a subtract, now here we'll have to contend with that little divot thing there, but it's actually really easy. So I've got this modeled at 50 millimeters thick, and this is dropping down, I think it's 50 millimeters. So we could actually just come in here, take this, zero that out. Come on. So now that goes all the way through, and then do a F12 and bring it up to the thickness that we want. So let's just say it's 20 millimeters. We want it to be 20 millimeters from the bottom of this pocket to this top surface. We just come in here, do 20, and merge high. And there's my dog. Apply and then cancel. Now we would come in here and just create a toolpath for this. So we would do a toolpath. I always use 3D, but you could do a 2D pocketing toolpath because all it is just a flat. Do a couple step down roughing bits, leave you a little extra material to come in here and do a finish bit with your 1-inch ball nose and clear that out. And for these toolpaths here, just show you what I did with them. So I'm actually using a 1/4-inch bit to come in here, so there's not a lot of tool contact because I don't know the diameter of those. Those might be just 1 inch. I don't know. But having a smaller tool go in there and do multiple passes on it will hopefully reduce catching and doing that chip out of the wood. I hope I made this as clear as mud. Hope you get something from it, Gary. And if you need me to elaborate on it, just let me know. All right.